Another way you can think about functions is to think of them as a machine. And this is sort of a way to kind of gamify things a little bit and make this a little bit more interesting than just working with, X's and Y's on paper. So think of the function as a machine. You're going to insert a number into the machine, and then the machine is going to grind and crunch and do some math, and then it's going to spit out an output. It's going to spit out a number. So you're going to put in a number, the machine's going to spit out a number after it's done something to your number. So input and output. X is the input, output is the Y. X is also called the independent variable because X is anything you want it to be, completely independent of everything else. You can stick anything you want into the function. But the Y that comes out depends on the X that you put in. So the output here depends on the input that you used. So X is independent input, Y is dependent, and it's the output. So let's say we're going to create a function machine where the machine is going to take the input, it's going to double it, and add 4. And that's what it's going to spit out. Find the outputs for the given inputs. So we're putting in an X value, right? That's our input. And what this machine is going to do is it's going to double that. So it's going to do 2 times X, and then it's going to add 4. And that's what it's going to spit out. It's going to spit out a number that goes along with the number that you put in. So if we drop in a 0 into this machine, then the machine is going to put the 0 in here. It's going to double it and then add 4. And it's going to give an output of 4. So when you put in 0, the machine spits out 4. If you put in 1, the machine is going to double it and then add 4, and your output would be 6. If you input a 3, the machine is going to double it and add 4, and that's going to give you 10. And then if you drop in a 5, the machine will double it and add 4, and you'll get 14. So you get these points, basically 0, 4, 1, 6, 3, 10, 5, 14, and those are all points that would be on that function if you were to graph them. Okay, we're not ready to graph yet, but this is a good way to think about functions because it's a little bit more easily understandable if you treat it like a machine with input and output. I think that's a little more understandable than just doing stuff on paper. And then we can go into what's called a composition of functions, which is like when you have a function machine attached to another function machine. So you might have seen this in college algebra. The composition of functions looks like this: G and then a little circle. It looks like golf, or if you write it the other way, it looks like fog, but it's not really an O, it's just a little circle. So G of F, that means you're not just plugging a number into your function, you're plugging an entire function into your function. So your input is another function. So when it is written like this, G of F, that's like saying that the F of X function is being plugged into the G function. So look how this is going to work. We have 2 function machines. We're going to drop a number into the inside function, so the F. Then it's going to grind and crunch, spit out a number that's going to get dropped into G, and then G is going to grind and crunch on that number and spit out your final input. So it's just like we have joined machines. So the equations we're going to do are 7x, that's going to be our F of X. And then x minus 5 is going to be the G of X. So you can see my first machine is 7x, my second machine is x minus 5. So find the output if the input is 2. So we're going to drop in a 2. So the 2 is going to get plugged into the F function. So the F function machine gets a 2 dropped into it, and 7 times 2 is 14. So then 14 would fall out of the first machine and fall right into the second machine. So then in the G function, we're going to plug the 14. So again, we're taking this output and making it the input for the next one. And what do we do? What does the G machine do? It takes your input and subtracts 5. And so what you're going to get here is 9. My pen is trying to run out of ink here. So 9 is what we would get for that one. Let's try another one. Find the output if the input is -3. Okay, so we're going to drop -3 into the top. So -3 is going to go into F, and it's going to multiply by 7 and give us -21. And then -21 is what we're going to drop into the G function. So -21 comes in here, and we subtract 5, and that's going to be a -26. So that would be your output. So this is called a composition of functions, because you're combining functions together, you're composing them. That's what that means. Now it says, find the output if the input is X. And the hint I'll give you is, if the input is a number, what's going to come out is a number. But if your input is generic, you can expect the output to also be generic. So check this out. If I drop an X into my function, then it just tells me 7x. It's going to spit out 7x. It's going to say, okay, I'm going to multiply your input by 7. So I inputted x. So it's going to spit out 7x. And then 7x is what's going to get put into the G function. So 7x that comes out is going to get dropped into the G function. And we're going to subtract 5. So the first thing that happens generically is it gets multiplied by 7, and then it gets 5 taken away from it once it makes it to the second machine. So that's how you would do a composition of functions. For me in my brain, like, I really like the concept of a function machine. That really helps me understand it.